So when we talk about signed numbers, what we mean is positive numbers and negative numbers. So remember, we have our whole numbers, 0, 1, 2, 3, 4, 5, 6, and so on forever. If we add in their negatives, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, and so on forever, what we have are integers. So the integers are the negative versions of the whole numbers with a 0 and then our whole numbers, 1, 2, 3, and so on forever. And so we have integers represented on this number line. We have positive numbers to the right of 0. We have negative numbers to the left of 0. So if we have this minus sign, this negative sign before a number, negative 3 is what this means. A minus 3 means negative 3. And on a number line, negative 3 is right there to the left of 0 because it's a negative number, 1, 2, 3 units. The number 3 on its own or the number 3 with a plus sign in front of it both indicate a positive 3, and positive 3 is over here. 1, 2, 3 units to the right of 0 with the positive numbers. And 0 is not positive or negative. That's why it's in the middle. It separates the negative numbers from the positive numbers. So we're going to compare any integers just like we would compare whole numbers. For any two numbers graphed on a number line, the number to the right is the greater number and the number to the left is the smaller number. So it's said just like we would compare whole numbers. If we had whole numbers 3 and 5, we obviously know 3 is less than 5. The symbol for less than is this. So it points to the left and it is open to the right. 3 is less than 5. Looking at the number line, 3 is to the left of 5. The number to the left is the smaller number. So an example we just had, 3 and 5. 3 is less than 5. Greater than is the symbol in the other direction. It points to the right. It's open to the left. So let's just again say, if 3 is less than 5, 5 is greater than 3. The number to the right is the greater number. So 5 is greater than 3. I like to say Pac-Man likes to eat. He's always hungry. And he would always prefer a bigger meal. Pac-Man will always be eating the larger number. So that could help you remember which sign is which. Now, when we compare negatives with negatives, it's not as simple as just looking at the number itself. We need to think about location. So let's look at negative 5 and negative 3. Negative 5 is to the left of negative 3. So negative 5 is less than negative 3. 5 is not less than 3, but negative 5 is less than negative 3. Or we can also write this as negative 3 is greater than negative 5. Negative 3 is to the right, so negative 3 is greater than negative 5. So let's do some examples. Let's compare 8 and negative 8. We want to insert less than or greater than between each pair to make a true statement. Well, any positive number is greater than any negative number because positive numbers are on the right. Negative numbers are on the left. So any positive number will be farther to the right and greater than any negative number. That same logic, we have negative 11 and 0. All negative numbers are to the left of 0, so all negative numbers are less than 0. And negative 15 and negative 14. 15 might be greater than 14, but negative 15 is actually less than negative 14. Because if we zoom in on that number line and look at negative 15 and negative 14, negative 15 is to the left. The number on the left is the smaller one. So negative 15 is less than negative 14. Now let's talk about something called absolute value. So the absolute value of a number is the number's distance from 0 on the number line. And the symbol for absolute value is 2 vertical bars. And what we want to take the absolute value of will be inside of those vertical bars. So here we have the absolute value of 2. Now absolute value is the number's distance from 0 on the number line. 2 is 1, 2 units away from 0. So the absolute value of 2 is 2. The absolute value of negative 2. Well, negative 2 is also 1, 2 units away from 0. So the absolute value of negative 2 is also 2. So what we've noticed, a helpful hint, the absolute value of a number is distance from 0. Distance has to be positive. It cannot be negative. So the distance from 0 is either always 0 or positive. It's never negative. So it's 0 when we have the absolute value of 0. How far away is 0 from 0? 0 units. But the absolute value of any negative number is always going to work out to be a positive number. So the absolute value of negative 6 is positive 6, because negative 6 is 6 units away from 0. So think of this as the make it positive sign. And let's work these examples. The absolute value of negative 8 would just be positive 8. The absolute value of 9 is 9. So a negative number becomes positive. A positive number stays positive. Don't make it negative. Absolute value means distance from 0. So it's always positive. How far away from 0 is negative 15? 15. The absolute value of a negative is the positive. Now, similar but different is the concept of opposite numbers. Opposite numbers are two numbers that are the same distance from 0 but on opposite sides of 0. For instance, 5 and negative 5 are opposites. Here's negative 5 over here. Here's positive 5 over here. They're both 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 units away from 0. So that's just a lot of words to say that a positive number and a negative number, when they're the same number otherwise, are opposites. If I asked you what the opposite of 5 was, you probably could have just said negative 5 without even thinking. So opposites is a very good word for this. We use a negative sign to indicate the opposite of something. So the opposite of 4 is negative 4. The opposite of 4 is written like this. And the opposite of a positive is a negative. The opposite of a negative is a positive. So the opposite of negative 4 would look like this, the opposite of negative 4. And the opposite of a negative is a positive. So if A is a number, any number, the opposite of the opposite of that number is the number itself. If the opposite of a negative is a positive, and the opposite of a positive is a negative, we've just said that the opposite of an opposite is what you started with. So if A is a number, the opposite of the opposite is that number. So if we have 3, the opposite of negative 3 is 3. If we have negative 3, then the opposite of negative 3, the opposite of positive 3, would be negative 3. And in this example, we started with negative 3. For right now, if everything I said about this didn't make sense to you, you can go back and listen to it one more time, but don't worry so much. As long as you understand that the opposite of a positive is a negative and the opposite of a negative is a positive, you're good to go on. Another helpful hint, 0 is neither positive nor negative. So the opposite of 0 is just 0. So let's find these opposites. The opposite of 14 is negative 14. The opposite of negative 3 is positive 3. Here's some more questions about opposites, but it's written with the negative notation. The opposite of negative 5 is positive 5. Here we have the opposite of the absolute value of negative 8. But what is the absolute value of negative 8? So this is the opposite of what actually? Well, it's the opposite of positive 8. And what is the opposite of positive 8? It's negative 8. So the absolute value makes this positive, negative 8. Negative 8. And then down here, we have the opposite of the absolute value of 3. Well, the absolute value of 3, equals, the absolute value of 3 is just 3. So the opposite of positive 3 is negative 3. When we think about adding real numbers, if we have positive and negative, our starting point on the number line is the first number. Adding a number moves us right. Subtracting a number moves us left. So if we have negative 5 plus 2, starting at 0, negative 5 would take us to negative 5 on the number line, so we could start there. Adding 2 moves us 2 units to the right. Negative 5 plus 2 would be negative 3. But it's not always convenient to think about the number line, so we're going to go over some additional rules to help us get our answers. If we're adding two numbers that have the same sign, we're going to take their absolute values and add them, and then use the common sign as the sign of the sum. So our answer gets the sign that is common to both. One A, we have 8 plus 11. You might be thinking this is a no-brainer. 8 plus 11 is 19. But we see we're adding two positive numbers. The absolute value of both positive numbers are just 8 and 11. We add those up to get 19, and 19 is positive because the common sign was positive. Negative 3 plus negative 15. Our common sign is negative, so our answer will be negative. And we just add the absolute values. 3 and 15 would be 18. So negative 18 is the answer. If we think about the number line, if we're at negative 3, and we move 15 more units to the left, we've gone more negative, and we end up at negative 18. In 1C, both numbers are negative and we're adding, so our answer will be negative. 14 plus 35 is 49. So our answer, negative 49. In 1D, we have fractions. Negative 3/5 plus negative 1/2. Both are negative, so our answer is negative. And we need to add the absolute values. So 3/5 plus 1/2. We need a common denominator. That's going to be 10. 10 is the first number in common if we look at the multiples of 5 and 2. 5 times 2 is 10, so 3 times 2 is 6. 2 times 5 is 10, so we do 1 times 5 is 5. That's 11/10. So our answer, negative 11/10. Don't worry about changing that to a mixed number. We did not have mixed numbers in our original problem, so we do not need to make our answer a mixed number. Now, if we're adding two numbers with different signs, we still take the absolute values, but this time we subtract them. And then whatever sign comes from the number that had the largest absolute value is the sign of our answer. In 1E, we have negative 9 plus 5. So we're adding one negative number plus one positive number. If we take the absolute values, we would have 9 and 5. 9 minus 5 is 4. And which of these numbers had the largest absolute value? The negative 9 did, because 9 was bigger than 5. Since the absolute value, answer 9, came from the negative number, our answer is negative. If we think about the number line, if we started at negative 9 and moved 5 to the right, we would still be negative, but we would be closer to 0. So we ended up at negative 4. One F. 16 plus negative 25. We look at the absolute values. We have 16 and 25. 25 minus 16 is 9. Since the larger absolute value of 25 came from a negative number, our answer is negative. (1g). We have decimals now. Negative 15.3 plus 27.03. The absolute values would be positive 15.3 and positive 27.03. If we subtract, we put in a placeholder 0. We get 11.73. The larger absolute value came from the positive number, so our answer is positive. And again, that makes sense. If we're at negative 15 or so, and we're adding or moving to the right about 27, that's going to move us right past 0 and into the positive numbers. And 1h. We have the fractions positive 1/2 plus negative 5/8. Our absolute values are 1/2 and positive 5/8. If we subtract these, well, first let's take a common denominator. The common denominator would be 8. 5/8 minus 4/8 is 1/8. The larger absolute value came from the negative number, so our answer is negative 1/8. So just to quickly review, when we're adding two real numbers with the same sign, we add the absolute values and use the common sign as the sign of the answer. So same has us adding absolute values. Different signs has us subtracting. Plus for same, minus for different. And remember, when we subtract the absolute values, whether it's positive or negative depends on which number had the larger absolute value. So we'll pick right back up with 1i. Negative 7 plus negative 23. We're adding numbers with the same sign, negative, so our answer is negative. The absolute values are 7 and 23, and when we add those, we get 30. So negative 30 is our answer for 1i. For 1j, negative 42 plus 38. Adding two numbers with different signs, the larger absolute value is 42. That comes from a negative number, so our answer will be negative. 42 minus 38, subtracting the two absolute values, gives us 4. So our answer is negative 4. If we think about the number line, we start at negative 42, move 38 to the right. It's not quite enough to get us to 0, so we have a negative number that is much closer to 0. than negative 42. 1k (53) plus negative 22. We're adding two numbers. They have different signs. The larger absolute value would be 53. That comes from a positive number, so our answer is positive. 53 minus 22 is 31, so our answer is positive 31. And 1L. Negative 5/12 plus positive 3/8. Adding two numbers with different signs. In order to compare them, let's look at the absolute values, but with a common denominator. So I started to write the denominator would be 12, but it wouldn't, because 12 is not a multiple of 8. It would actually be 24. So 5/12 would be 10/24. 3/8 would be 9/24. So the larger absolute value comes from the negative number. Our answer is negative. We subtract the absolute values because they were different signs. 10/24 minus 9/24 leaves us with 1/24. So negative 1/24 is the answer. And subtracting real numbers, we can just take the basic rule that subtracting two numbers, a minus b, would be a plus the opposite of b. So subtraction is just adding the opposite. And we're starting with 1a through h, where we're just given a bunch of numbers to subtract. So in 1a, we have negative 8 minus 4. Subtraction is adding the opposite. So instead of subtracting positive 4, we are adding negative 4. So whenever we have minus something, we can change it to plus the opposite. Adding two numbers with the same sign. Since they're both negative, our answer is negative. 8 plus 4 is 12. Think of the number line. If we started at negative 8 and subtracted by moving left 4, we end with negative 12. So 1b, 11 minus 18. This would be 11 plus negative 18, adding two numbers with different signs. The larger absolute value comes from the negative, so our answer is negative. 18 minus 11 is 7, so our answer is negative 7. Number line starting at 11, moving 18 to the left, is going to move us past 0 into the negative numbers. Now 1c, if we go by the definition, subtracting is adding the opposite. There's so many signs in play here that I don't blame you if you get confused. We would be adding the opposite of negative 10. But the opposite of negative 10 is positive 10. Look how this changed the problem. Minus a negative just becomes plus. So if you want to jump straight from minus a negative to plus, that's going to work for you. Adding two numbers with different signs, the larger absolute value comes from the negative number. So our answer is negative. 15 minus 10 is 5. So however you do it, you're going to end up with negative 5. (1D). We have negative 12 minus 12. I want you to look at that for a second. Okay, you think you have the answer? Well, if you're thinking it's 0, you are wrong. We're not adding opposites here. We see 12 twice. But it's negative 12 minus another 12. On the number line, we're moving left. We're going to end up with negative 24. So this is plus negative 12. Adding two numbers with the same sign, that's negative. 12 plus 12 is 24. (1E). 22 minus negative 13. Minus a negative we can change to a plus. 22 plus 13 is 35. Again, minus a negative. For negative 132 minus negative 207. Minus a negative can be changed to plus. We're adding two numbers with different signs. The greater absolute value comes from the positive number. So our answer will be positive. We just need to do 207 minus 132. That's 75. Our answer, positive 75. (1G). We have 1.3 minus 3.8. This is 1.3 plus negative 3.8. Subtraction is always adding a negative. Adding two numbers with different signs, the larger absolute value comes from the negative number. 3.8 minus 1.3 is 2.5. So negative 2.5. (1H). 15 over 7 minus negative 9/14. Well, minus a negative is plus. So we're adding 15/7. and 9/14. We need a common denominator. That's going to be 14 itself. So the 9/14 stays like it is. But 7 to 14 was times 2. So 15 times 2 is 30. We get 39/14. There's no number that can divide 39 and 14 evenly, so we cannot reduce. And again, even though it's improper, we don't have to worry about changing it to a mixed number. Not only weren't there mixed numbers in our original question, but they actually started by giving us an improper fraction, so this is okay. To A, we have -3 minus -4 minus 5 plus -2. So remember, order of operations tells us addition and subtraction happens in the same step from left to right. So let's work from left to right. -3 minus -4 minus a negative is plus. -3 plus 4 is +1. That one's pretty easy if you think about the number line. Start at -3, move 4 to the right, you're at +1. But if you're doing the rules, we're adding two numbers with different signs. The larger absolute value comes from the positive number, and 4 minus 3 is 1. Don't move on this way yet, because we have 1 minus 5 now. That would be 1 plus -5. So we're adding two numbers with different signs. The larger absolute value comes from the negative number, and 5 minus 1 is 4. So we have -4 plus -2. We're adding two numbers with the same sign, so our answer is negative because the common sign was negative, and 4 plus 2 is 6. So 2a would be -6. To B, (7 minus 10 minus 8 plus -7). Left to right, because it's all addition and subtraction. 7 minus 10 would be 7 plus -10. And if you get -3 right off the bat, go for it. I'm just showing the steps for those of you who are still struggling with this. You're more than welcome to just jump straight from 7 minus 10 to -3. But otherwise, we're just going to follow the rules. So subtraction is adding a negative. Adding two numbers with different signs. The larger absolute value is negative number. And 10 minus 7 is 3. Minus 8 plus -7. So -3 minus 8 is -3 plus -8. Adding two numbers with the same sign. That sign is negative. 3 plus 8 is 11. Finally, adding two numbers with the same sign. That sign is negative. 11 plus 7 is 18. Again, you don't have to do it that way. Let's look at this same problem. If we wanted to change this plus negative 7 since adding a negative is subtracting, you can go 7 minus 10 is negative 3. Negative 3 minus 8 is negative 11. Negative 11 minus 7 is negative 18. However you're thinking about it. So 2C. Now we're going to treat the absolute value like a grouping symbol. And we're going to do it first. Negative 3 minus 5. That's going to be negative 8. And the absolute value of negative 8 is positive 8. Exponents next. 3 squared is 9. So finishing this up, negative 2 plus 8, that's going to be positive 6, minus 9. Hopefully you got an answer of negative 3. So for multiplying real numbers, the rules are pretty simple. If they have the same sign, our answer is going to be positive. And if there are different signs, our answer is going to be negative. Zero. Anything times 0 is 0, and 0 times anything is 0. It doesn't matter whether the number we're multiplying by is positive or negative. Here we see negative 6 times 0 is 0. 0 times positive 125 is 0. Exponents, remember, is just repeated multiplication. So if we have an odd exponent and we're multiplying a negative number times itself an odd number of times, we're going to end up with a negative result, because every pair of negatives would become positive. Negative 3 times negative 3 is positive 9. Times negative 3 would give us negative 27. By similar logic, an even exponent is going to give us a positive result, because every 2 become positive. Negative 2 times negative 2 is positive 4. Negative 2 times negative 2 is positive 4. Positive 4 times positive 4 is positive 16. Or we can look, negative 2 times negative 2 is positive 4, times negative 2 is negative 8, times negative 2 is positive 16. So odd exponents give negative results, even exponents give positive results. (1a), we have negative 6 times 5. 6 times 5 is 30. Negative times positive is negative. So negative 30. In 1b, we have negative 11 times negative 3. Negative times negative is positive. 11 times 3 is 33. In 1c, we have negative 3/5 times positive 10/21. We know that our answer is going to be negative because it is a negative times a positive. So we multiply fractions just like normal. 3/21 can be reduced to 1/7. Both the 3 and the 21 can be divided by 3. And our 10 and 5 can both be divided by 2. So our answer is negative 5/7. One D. We have a string of numbers now. Positive 2 times negative 5 times negative 1 times negative 3. So first we'll see, are we going to have a positive or a negative result? We have 1, 2, 3 negatives. So our answer is going to be negative. An odd number of negatives gives us a negative answer. 2 times 5 is 10, times 1 is still 10, times 3 is 30. So negative 30 will be the answer here. In 1E, we have negative 8 squared without parentheses. That means that the square only applies to the 8. 8 times 8 is 64. And we carry that negative through because it was not being squared. One F. Now we have negative 7 squared with parentheses. That means that it is the entire negative 7 that we're squaring. Negative times negative is positive. So positive 49. In 1G, negative 1 to the 8th. Notice that the negative is not in parentheses, so it's not a negative number to the 8th power, it is just 1 to the 8th. 1 times itself, no matter how many times, is just going to be 1. So 1 to the 8th is 1, and we bring the negative through. Negative 1 is the answer. And in 1H, negative 1 in parentheses, raised to the 87th power. A negative raised to an odd power is going to give us a negative number. And again, 1 to any power is 1. So just to show something different here, here's an example I'm just making up right now. Let's say it was negative 1 to the 8th in parentheses. Well, then we would have an even power, a positive answer, and 1 to any power is 1. So if we had negative 1 in parentheses to the 8th, that would be an answer of positive 1. Reciprocals. Another word for reciprocal is the multiplicative inverse. Reciprocals would be two numbers whose product are 1. So if we have 1/2, what would we have to multiply to get an answer of 1? Well, the 2's would have to cancel and the 1's would have to cancel. So 1/2 and 2, because 2 over 1 is 2, would be reciprocals. So when it comes to fractions, we just flip it. A note, 0 does not have a reciprocal, because if we think of 0 as 0 over any number, let's just say 1, in order for it to have a reciprocal, the zeros would have to cancel. But we cannot have 0 on the bottom of a fraction, so 0 does not have a reciprocal. Three sevenths would have a reciprocal of 7/3. Just flip the fraction. 2b, we want to find the reciprocal of 5. We know that 5 is 5 over 1, so the reciprocal would be flipping that fraction and getting 1/5. 2c, negative 5/21. Reciprocals do not change the sign. So when we flip that, we will get negative 21 over 5. Two D. .3. Well, you might be tempted to make this 1 over 0.3, but that's a mix of a decimal and a fraction. So really, we would want to change this 0.3 to 3/10, the fraction equivalent. So its reciprocal would be 10/3. How else could we have gotten there? Picture 0.3 over 1. Flip it. We would get 1 over 0.3. And we can't have decimals inside of fractions, so we move the decimal one place to the right everywhere. We get 10/3 that way as well. A quotient of two real numbers. As far as the signs go, the rules are the same. If the numbers have the same sign, our answer is positive. If the numbers have different signs, our answer is negative. 0 again. 0 divided by any number is 0, but a number divided by 0 is undefined. So, 5 divided by 0. We have 0 on the bottom, dividing by 0. Undefined, because we can never divide by 0. But 0 over -9, that's fine, and the answer is 0. Again, it doesn't matter if we're dividing by a positive or a negative number. 0 divided by something, as long as that something is not 0, is going to give us 0. And notice we could put a negative sign on the bottom, on the top, or on the outside. So a over negative b is the same as negative a over b is the same as negative a over b. Top or bottom or outside, but not both, because both top and bottom would be negative divided by negative, and that would be positive. .3a we have positive 27 divided by negative 3. Positive divided by negative is negative. 27 divided by 3 is 9. 3b, we have negative 90 divided by negative 5. Negative divided by negative is going to give us a positive answer. So we just have to figure out what negative 90 divided by negative 5 is. 5 goes into 9 one time. Remainder 4. Bring down the 0. So that's going to be 18. Look at 3C. Negative 1/2 divided by negative 8/15. Negative divided by negative will be positive, so we can just do 1/2 divided by 8/15, which would be 1/2 times 15 over 8, which gives us an answer of positive 15 over 16. And 3D, negative 22 over 0. We cannot divide by 0, so this one is undefined. Okay, so let's simplify. Fraction bar is 2 problems. The bottom is done. It's just a negative 4. On the top, we have negative 8 times 3. Remember, different signs when we multiply is a negative number. Negative 8 times 3 would be negative 24. Finishing this off, negative divided by negative is positive. 24 divided by 4 is 6. So this would be positive 6. Go ahead and try this one. 24 plus 19 plus negative 3 squared. And pay attention to where those parentheses are and what that means when you're squaring. If you said 34, you are wrong. If you have 34 or you're not done, go ahead and pause to try this again or to finish, because here come the spoilers. So we have to do exponents first. Negative 3 squared with the negative inside the parentheses means negative 3 times negative 3, which is what? Positive 9. So this is 24 plus 19 plus 9, not minus 9. If you did minus 9, you ended up with 34 and got the wrong answer. Instead, we have to do 24 plus 19 is 43. Plus 9, whoops, is 52. So 3 more examples. I'd like you to try all 3 of these. Let's get them all on the screen at the same time. There we go. So 1, 2, 3. We have 4 times the quantity 5 minus 2 plus 4 squared. Then we have negative 5 squared plus negative 7 squared. This time the negative 7 is in parentheses. Minus 1 cubed. Negative 5 squared plus negative 7 squared minus 1 cubed. And then over here, we have 4 times the quantity 6 minus 9 plus negative 6 minus radical 49. So go ahead and do these 3. And pause, because I'm going to start the answers right now, starting with the top. Okay, first, inside parentheses, 5 minus 2 is 3. So 4 times 3 plus 4 squared. The exponents. 4 squared is 4 times 4, that's 16. The multiplication, 4 times 3 is 12. And then finally, 12 plus 16 is 28. Next, negative 5 squared without the parentheses is negative 1 times 5 squared. So this is negative 25, not positive because it's not in parentheses. Then plus negative 7 squared. This is in parentheses, so negative 7 times negative 7 is positive 49. Minus 1 cubed is 1 times 1 times 1, which is 1. So we have negative 25 plus 49, which is the same as 49 minus 25. That's going to be positive 24. We're adding 2 numbers. Their absolute values. We're adding 2 numbers with different signs. The absolute values are 49 and 25, which gives us the 24. The larger absolute value was 49. 49 came from a positive number, which is why it's positive 24. Minus 1 gives us an answer of 23. Finally, for these sorts of problems, working in parentheses gives us 6 minus 9 is negative 3 there, plus negative 6, nothing to work on, minus the square root of 49 is 7. 4 times negative 3 is negative 12, plus negative 6 minus 7. We have to do addition and subtraction from left to right as we come to it. We're adding 2 numbers. They have the same sign. Their absolute values are 12 and 6. Add those together, we get 18. But they're both negative numbers, so it's negative 18. Negative 12 plus negative 6 is negative 18. Minus 7, we're getting more negative. We can also think of this as negative 18 plus negative 7. Either way, we're going to get an answer of negative 25. 18 plus 7 is 25. The numbers we're adding are both negative, so it's a negative 25. A variable is a letter. We'll talk about what that letter means in just a second. But an algebraic expression is a combination of operations on letters, variables, and numbers. So for instance, 5 plus x, 6 times y, 3 times y minus 4 plus x. We're adding, subtracting, multiplying, dividing combinations of letters and numbers. Now, 6 times y, 3 times y. When we're multiplying, we're just going to jam these together. 6y, 3y. So if we had 4x, that would mean 4 times x. If we had xy, that would mean x times y. See, because these are letters, we can just put them together. And when it's just together, that means multiply. Why couldn't we do that with numbers? Well, 1 times 3, if we just wrote those together, we'd have the number 13. That's confusing. Is this 13 or is this 1 times 3? So with numbers, if we put them together, we would have to put them in parentheses. Oh, that looks horrible. We'd have to put them in parentheses. 1 times 3. If we had x times y, there's no confusion if we just jam it together. xy. So that means x times y. If we replace a variable in an expression with a number and then find the value of that expression, it's called evaluating the expression for the variable. Now, let's break this word variable up a little bit. We've said it enough times. And all we know about it so far is that it's a letter. What's it mean? Well, in variable, V-A-R-I should make you think of varies. The variable varies. Until you assign a number to it, a variable stands for any possible number. So if we had, for instance, x plus 4, what we're saying is any number plus 4. We can't give this a value because 1 plus 4 is different than 2 plus 4. But if we said, hey, x equals 3, once we know x equals 3, we can go, well, then instead of x, we have 3. 3 plus 4. When we're given a value for the variable, then just like the old Glade commercial says, plug it in, plug it in. Once we have all numbers, we can evaluate. When x is 3, x plus 4 equals 7. But if we changed x to 2, then x plus 4 would be 2 plus 4. It would be 6. So let's evaluate x minus 2 if x is 7. Plug it in, plug it in. X is 7. Then instead of x minus 2, we have 7 minus 2. And 7 minus 2 is 5. Another example. Y times x minus 3. For x equals 8 and y equals 4. So instead of y, we have 4. Instead of x, we have 8, and then we have minus 3. Order of operations, work inside the parentheses first. 8 minus 3 is 5. And look, even if we leave it in the parentheses, that's a great idea because we know right next to each other means multiply. 4 times 5 is 20. Another example. Evaluate y plus 6 over x for x equals 6 and y equals 18. Instead of y, we have 18 plus 6 all over, and instead of x, we have 6. Order of operations, do top and bottom separately. So the bottom is just 6 still. On top, 18 plus 6 is 24. And then 24 divided by 6 is 4. Let's go again. We have 25 minus z cubed. There we go. Z cubed plus x for z equals 2 and x equals 1. Now, when we're plugging in with exponents, it's a good idea to put the space for the variable in parentheses. So instead of z, we have 2. So this is going to be 2 cubed. The reason the parentheses are important is what if we were plugging in a negative number? Remember that a negative squared is different depending on whether the negative is part of the base or not. So if this was a z equals negative 2, we would want the whole negative 2 raised to the power. So when powers are involved, plug in inside of parentheses. Better to be safe than sorry. And there's no partial credit for a little mistake like that. You might do everything else in the problem right, but get the wrong answer. That is still wrong. With math, arithmetic, you can't get partial credit in real life. I know this is an extreme example, but what if your math was for a building? What if you were an architect and your math was for a building? And the building falls down because you made a mistake with a number somewhere, but you did everything else right. Guess what? That building still fell down. Not a lot of people are going to think you deserve partial credit for that. Building's gone. So that's why attention to detail is very important in math. Okay, we're still plugging in here. Sorry for the tangent, but it's for your own good. Plus x, x equals 1. So, order of operations says do this exponent. 25 minus 2 cubed is 2 times 2 times 2. That's 8. We have addition and subtraction left, so we hit it from left to right in the order we come to it. 25 minus 8 is 17. 17 plus 1 is 18. Okay, let's talk about terms.